So recently, a couple people have tried to talk me into creating something called a gravity light. And at first I wasn't really interested because it seems like, other people have built them, they already exist. And I thought, if I can't add anything to this, there's no reason for me to go ahead and just build one. But then, I came up with a really neat idea for how I could go about doing this. So let me show you guys my plans, and then we're going to get into actually drawing it and creating it, and printing it and making it. But we'll see how this goes. So the idea of a gravity light is to hang a weight on something with the rope wrapped around a pulley a bunch of times. You let the weight go, gravity pulls the weight down, and the force of the weight being pulled down turns into the pulley turning, rotating the generator and creating electricity. And then electricity turns on a light. Instead of a light bulb, you could have, let's say, a cell phone, which would be an iPhone in this case, because iPhones are cool. Now, this isn't very useful to me in the country that I live in, but at places where they don't have light, places where there's been recent big storms and there's power outages, this is very useful because you could just lift up a 5-pound weight hanging on something and charge up your cell phone or an emergency light or a flashlight very easily rather than cranking a generator. So now that you guys know the purpose of a gravity light, it's time to talk about some very important design considerations. A gravity light would only be used in a situation where you can't get power and thus you can't make an expensive thing. So there are two things that I want to show you, and this is what relates back to that. Any motor that has permanent magnets can very easily be used to generate electricity. So this is a brushless motor and this is a DC motor that has brushes that commutate. Both of these will generate electricity. This one will generate DC electricity that's very noisy. This one will generate AC electricity. But there is a very important difference between these motors in that this motor costs, let's say $40, and this one costs maybe $4. Now, the important difference in these two motors is that if I go ahead and short out the leads on this one, so there are only 2 leads on this motor, and I'm going to go ahead and short them out with my needle nose pliers. And I go and spin the flywheel on this. You notice this flywheel doesn't really have a whole lot of resistance due to the motor being shorted out. It doesn't seem to care that much. So I'll go ahead and unshort the motor. And it does spin a little bit longer without it shorted, but not that much. So then there's this motor, and this is an outrunner, so actually it's the back of the motor that spins. And you'll notice this one spins pretty freely, but if I go and short this motor out, I don't have enough hands. Push the trigger of the drill, hold on to this part, and then I'm going to short these 2 leads. Now, what I want you to notice here is how much more this motor is able to stop me from spinning it. Even from the 2 leads there, now they're touching each other. And you could actually see sparks between these 2 leads. Now, what's going on here is that this motor is able to output a lot more voltage per RPM than this motor. And the reason that this one can output more voltage per RPM than this motor can is because this motor has a lot more windings, it has a lot stronger magnets, it has a larger diameter, and all of those things come into play. Ultimately, if you were designing a gravity light, what you would want to do is make sure that you made it as cheap as possible, meaning that using a motor or a generator like this is out. So the main problem with using this motor is that you need to spin this motor really, really fast in order to get a decent amount of voltage out of it. And the problem with doing that comes down to gearing. So gearing is when you have, let's say, a big gear and you have that up against a small gear. You turn this big gear, let's say 1 revolution. This small gear will rotate, of course, in the opposite direction, but it will rotate, let's say, 6 revolutions. Now you've got your gravity wheel. Let's say you have a pulley on this and your weight mounted to that weighs 5 pounds. Now you turn this 1 revolution by pulling your weight down, your motor spins 6 times with 1/6 of the torque that your original shaft has, and there you go, you got your gravity light. But the problem is that's not even fast enough. So now you add another big gear onto the same shaft as your small gear here, and you say that for every 1 rotation of this gear will make 6 rotations. So now you got a 36-to-1 reduction. So this shaft spins once as your weight's falling down, and then this shaft will spin 36 times. So let's say that your main shaft moves 10 degrees, and let's just assume that's this far. Now your DC motor here is only going to move 1 revolution. This weight is going to fall in less than a minute. So that 36-to-1 reduction that you thought was adequate actually needs to be like 360-to-1. And the problem is that when you keep increasing this gear ratio, you could keep doing the same thing over and over again. This is the big gear, this is a small gear, this is the big gear, this is a small gear. You end up with a very, very inefficient system. This whole system right here, to get to the ratio that you might think you need, might only be 10 to 30% efficient. And I bet you that 30% is at the high end. So this whole system, this is the reason why I didn't want to create my own gravity light. But then I came up with a new idea. You see, a while back I saw this article about a guy by the name of Manu Prakash, if I'm saying that right, who developed a really interesting way to centrifuge blood for developing nations to see if someone had malaria. And what he did was this. He just created one of these little button spinner things into basically a centrifuge. And what's interesting about this button thing is that it spins really, really fast, and you input a very, very slow pulling motion in order to make this button spin so fast. In this case, it's actually a flywheel. And if this is not more efficient than this, I'll eat my lunch. I mean, this seems like this would be incredibly efficient. So I want to build this. I'm gonna build this, and I'll show you guys how I'm gonna build it. Let's get in the cab. Let's build this. Let's get to building this thing. Okay, so I'm getting this thing set up a little bit. I've got a flywheel, which I'm starting to realize is way too small, and a place to hook the rope onto. And I'm gonna go ahead and hook this flywheel up with this rope, and I'm gonna go ahead and tighten. I have to pre-wind this so that it has a direction to start with. So I'm gonna go, and in reality, if the generator part could work as a motor, you could use the motor to pre-wind it. So this isn't a big deal, this isn't a big gotcha, you know, yet. So now I'm gonna try to just run it by hand, so release it. Okay, so it worked there until I accidentally started lifting up my counterweight with my pulley here. I'm gonna try that again, because it seemed like I was getting closer to the right frequency that I needed to spin it to keep it going. So pre-wind. Nope, not enough pre-wind. So I'm realizing now this flywheel is way too small. Another issue is that it pulls off of this way too easy, so this outer part of this needs to be bigger, or I need to find a way to permanently attach the rope to it. Alright, I've got more parts. Alright, so I'm just about ready to give this another try. I've got new flywheels printed out, and I've got magnets in them, because they're gonna have magnets in the end anyways. And I've got a smaller pulley for the weight to pull on, so the weight will turn the shaft more times per inch of falling. It'll essentially push less torque into the shaft, which I think should help for why it wasn't working before. And I'm just hopeful that everything else works out. So I'll just get these nice and spun up, and then I'll hang the weight off the edge of the table, hold the thing down, and so close. Okay, so now that I know that the mechanical part of this machine doesn't work very well, it's time to figure out if the other part of this works. So what I did was I took apart one of these little electric motors and I stole a coil of wire out of it, wound it around a Sharpie, and then I soldered the ends to this little plug in the breadboard. So these should be the two connections to the motor. First off, I'm gonna do a continuity test on this wire to see if I've even accomplished that. Open leads. Oh, there we go. Maybe the resistance is too high to make my multimeter beat constantly. 38 ohms of resistance. So yeah, these two are connected. Now the curious part is their voltage here. I got an idea. Zip ties. 38 ohms of resistance, and let's check for AC voltage when I spin this thingamabobber right up above this coil. So I got 0.8 volts. I got almost a volt there. I was measuring AC voltage, which isn't going to be perfect for this meter. Well, I guess it claims to be true RMS, but I doubt it. And this is going to be a weird frequency. It's going to be all over the place. So yeah, it does work. You can generate electricity with this, and actually a volt isn't bad for just something that you spin by hand. I mean, that is, if there's any current behind it. This meter actually has some pretty good resolution for a current, so this could be interesting. It could actually show me what the short circuit current is. I guess it'd be even better if I could tell you the short circuit current and the voltage. So you might notice that I wrapped this through here 3 times. The reason for that is that the value will be 3 times higher and you'll get more resolution on it. And I just short circuited the coil. So let's see how much current I actually induce in this coil. So I've got 0 amps right now, and spinning it right next to the coil gives me 0.2 or 0.02 amps of AC current. I don't know, it's tiny amount of current and voltage from this little system that I've built. So how sad, right? Well, anyways guys, I don't think this is gonna work. This seemed like a lot better idea in my head than it did in real life, and that's why having a 3D printer is pretty awesome, because now I can try this out. I can find out that maybe it's not such a good idea, and then I can give up on it and be done with it. If any of you seriously think that there's something to this, something to the idea of generating electricity with a flywheel spinning on a little string spinner, let me know in the comments and maybe I'll come back to this project. Otherwise I'll just probably leave it alone, leave it at this. So thank you guys for watching. I hope you enjoyed me fail a little bit this week, and yeah.